I would never want to be 100 years old. You hear this all the time, and I can't help but being shocked. And I think, well, is that either number one, you don't love your life, or number two, you're fearful of what being 100 years old might mean? Might mean being old and weak and frail. What if I was to tell you that that isn't necessarily the case? That we could think about aging not as an inevitable part of life, but as a disease. Over the next few weeks, we're going to be talking about longevity, and there is a ton of information out there. Some of it's good information, some of it is just people trying to sell you cheap parlor tricks. All right, but today I want to start to look at the science and get you comfortable understanding what this idea of longevity is. So today we're going to define aging. We're going to talk about the informational theory of aging. All right, we're going to talk about some resources and some books that I think you'll find really interesting. We're going to talk about a health span versus lifespan. Okay, it's not just about living longer, it's about living healthier. And then finally, we're going to talk about the hallmarks of aging and what those targets might be, either from lifestyle and behavior changes or supplements, diets, other things that will allow us to increase our health span. All right, so this is a new deep dive on CitizenSurgeon. I'm so pumped you're with us. Let's go. Welcome back to CitizenSurgeon. My name's Dr. Eric Pearson, and today we're talking about aging. A little different than some of the previous talks. And we're going to talk about specifically aging as a disease. And over the next few weeks, we're going to introduce this concept of longevity, and I'm going to take a deep dive into the science. So this is an introductory video. Doesn't matter if you're a doctor or a non-doctor, just somebody interested in health, I think you're going to find a ton of value today. Now, why did I make this pivot? Why are we talking about aging? Well, this is a passion project of mine because I am constantly iterating after I read new research, read papers, read books, and trying to find how I can fine tune my own health. And so I wanted to share these things that I'm learning, these people, authors that I'm learning from with you. All right, because I think if we're going to learn anything about health, we need to learn about preventative medicine. We need to learn about how to increase our health span. How can we think about aging? Well, take this from Dr. Nir Barzilai. He is a researcher in aging, and he is one of the authors on the TAME study, which is targeting aging with metformin. And he says aging itself is the major risk factor for diseases like cancer, cardiovascular, and Alzheimer's. By targeting aging, we can prevent these diseases from occurring in the first place. And one thing I'm going to get to when we talk about health span and lifespan is that we all die of something. This concept of dying from old age doesn't really exist, all right? We're going to die of something. Now, Dr. Peter Attia, he refers to those things we're going to die of as the four horsemen, all right? And we're going to talk about that in a little bit. Well, there's another person that is famous in the longevity research and the aging research, and that's Dr. David Sinclair. And so how does he look at aging? Well, he would say aging is a disease and it's treatable. We can address it just like any other disease with preventative and therapeutic approaches. And so that changes how we look at aging, not just as a chronological march toward some inevitable outcome in our 70s and 80s, but if we think about aging as a disease, then there are choices that we can make that may have an impact on our longevity. For instance, caloric restriction. And there may be therapeutics that we can take advantage of to increase lifespan. And that may be things like NAD supplementation or working on our hormesis with cold and heat exposure. So over the next few weeks, we're going to go through a lot of these and we're going to dive deep into the science. But how do we start this conversation? Well, the best way I think to start the conversation on aging is to look at health span and lifespan. And I think this is why there's a lot of fear in wanting to be a centenarian, all right? And that's because it's not just about the years that we live, but it's how well we live those years. So can we be a 100-year-old person and do the things that a 50 or a 60-year-old person can do? I think the argument is absolutely. And so let's look at health span and lifespan. Well, let's look at lifespan first. So you can see in this chart here, we're going to start out, and on the y-axis, this is our percentage of health, okay? And as soon as we're born, there may be some limitations based on our genes, but we're going to call that 100%. And as we go through the first 40 to 50 years of our life, we're going to see a gradual decline in our health after our 20s. And for the normal human at about 45 years old, we're at about 50% of our health span. And that's because we may have obesity that's affecting us. We may have cardiovascular disease or chronic respiratory disease that's affecting us. So at about 45 years old, we're already at about 50% of our health span. Well, what happens after that? Well, after that, we're going to see our health decrease gradually until we're about 75 years old and we die of some disease. So the question becomes, what kills us? Well, there are several things that are going to end our life, okay? First, we could say accidents and non-accidents. But accidents in adults are not the major cause of death. Well, if we look broadly, the vast majority of people are going to die from cardiac or heart disease, chronic respiratory disease, cerebral vascular disease or stroke, cancer, neurodegenerative disease, or metabolic disease like diabetes. Well, how does this break down? Well, we can see here that heart disease and cancer are the two biggest killers. After that, we see metabolic diseases like diabetes as a big cause of death, followed by chronic respiratory disease, cerebrovascular disease, and neurodegenerative disease. Okay, so those are the major reasons why we die. We don't die just of old age. We die because of one of these things, all right? And so the question becomes, if we're going to die of one of those things throughout our life, is there anything that we could have done about it? Well, a lot of these diseases are preventable. Up to 80% of cardiovascular disease is preventable. Up to 50% of cancers are preventable. Think about it. Avoiding tobacco is important in almost every one of these diseases, okay? Making sure that we're getting our screening for cancers, whether that's breast cancer or colon cancer, making sure we're getting that colonoscopy at 45 years old. So a lot of these major causes of death are preventable to a certain extent. And they're preventable because of modern medicine, or as Dr. Peter Attia would say, they're preventable because of medicine 2.0. Now, what is medicine 2.0? Medicine 2.0 is basically our ability to diagnose and treat disease. Dr. Attia goes further in his book Outlive and talks about medicine 3.0. And that's kind of what we're getting at today. And that is preventing these diseases from happening. If we can prevent these diseases from happening by treating aging as a disease, and that these diseases are just a consequence of aging, then we might be able to get ahead of it and increase our lifespan, and by doing so, increasing our health span. We can see that modern medicine has kind of increased our lifespan a little bit, but even at that point, when we're treating cardiovascular disease and cerebrovascular disease and COPD and diabetes, we're really not improving our health. We're kind of just extending our life. And I think that's one of the arguments against wanting to be old, is you're just dealing with more disease. Well, what if it doesn't have to be like that? What is this concept of longevity and this concept of squaring the curve and increasing health span? Well, what that means is looking at this green line. So through behavior, so for example, having a healthy plant-based diet, avoiding smoking, limiting alcohol intake, reducing stress, having good mental health, getting enough sleep, and potentially using particular therapeutics. As the years continue, we might not have to just decay from that 100% of health. We might be able to continue it until the very end of our years, where we hope we just kind of fall off a cliff, right? We want to stay as healthy as possible until the end. So how do we do that? Well, we do that by first understanding aging. So there are a ton of definitions of aging. One is chronological. So that's just as the years go on. I mean, how many times have you been asked, how old are you? Well, I'm 45 years old, but what does that mean? I feel like I can do things that I could still do 10 years ago or 20 years ago, but I know a lot of other 45-year-olds that can't. All right, can they climb a mountain or go on a 100-mile bike ride? So that idea of chronological age really doesn't mean anything. All right, well, what's the next way that we can look at aging? Well, second might be biological aging. So those are the physiological changes that occur over time. And that might be cellular damage or damage to our vasculature that leads to cardiac disease and cerebrovascular disease. And that is termed also our biological age. Okay, so that's another way that we can define aging. Functional aging is where we look at our overall physical abilities and function and how those vary with time. So, as we get older, what things are we able to do physically and what things are we no longer able to do? In Peter Attia's book, Outlive, he talks about one of the most important things for longevity and living a long life, as well as having a high degree of health span, would be strength. We need to maintain our strength so we don't become weak, fragile, and then increase our risk from succumbing from disease, whether it's one of the major ones I talked about or whether it's falling and breaking a hip. Okay, that can be a life-ending accident. We can also look at psychological and social aging. And so that has to do with changes in cognition, in mental health, and even social roles in society. And how about pathological aging? Well, pathological aging is getting at, diseases that are age-related. So, for example, cardiovascular disease or cerebral vascular disease or cancer. The risk of breast cancer or colon cancer is much higher in somebody that's 80 years old than it is in somebody that is 20 years old. And then finally is this informational theory of aging. So Dr. David Sinclair wrote this book, Lifespan. I finished this book. I've gone through it a couple of times now. And what Dr. Sinclair contends is that aging is the loss of information. Now, our genes, they are fairly stable. So our genome is stable from the moment that we're born all the way until our last day. But what changes? What changes is the epigenome. And the epigenome controls how genes are expressed. And the epigenome is extremely dynamic. It is always changing in response to our behaviors and external stresses. And so Dr. Sinclair argues that aging is really due to changes in the epigenetic code, and that this isn't inevitable at all, but is due to behavior choices that we make and the environment that we choose to live in. And so if we're going to talk about the genome and the epigenome, we just should run through that so we can all use the same vocabulary. So the genome, that's the sequence of A's, C's, T's, and genes, all those nucleosides that are drawn together to then make that DNA double helix and how many 3 billion base pairs, okay, and that's going to be our genome. Well, that's wound super tight around histones, and all those histones, 8 histones come together to form a nucleosome. Those nucleosomes are then wrapped and wrapped and wrapped to form chromatin, and that chromatin is then wrapped and wrapped to form a chromosome. Okay, so you can see that in this cartoon outline. And so an epigenetic factor is on this DNA wound around histones, and it's going to influence gene expression. And so by changing those epigenetic factors, we're going to be able to change gene expression, whether that's for good or for bad. So, for bad might be if we're no longer expressing tumor suppressor genes, we may have an increase in the incidence of cancer. Taking aging and the epigenome a little further, we have a few terms. So one is the epigenetic clock. Well, what is an epigenetic clock? Well, Dr. Steve Horvath, who is a superstar researcher in aging, has looked at DNA methylation and how this is associated with different disease patterns. He's also shown that lifestyle changes, behavior changes, can repair DNA methylation patterns and sort of reverse this epigenetic clock. There's a concept of epigenetic drift. So you got mystery man here. Well, what's epigenetic drift? Well, a cell has its genome and its epigenome, but if there are enough changes in the epigenome, and there's enough changes to gene expression, then that cell may lose its identity. It may be a zombie cell or a senescent cell. Okay, and it's not good to have zombie or senescent cells in our body. All right, so that's epigenetic drift, is a change in those epigenetic factors, for example, methylation, that causes a cell to lose its identity and lose its function. Another concept is cellular reprogramming. Well, this could be a therapeutic strategy to kind of reverse the damage associated with aging. So how could we do that? Well, there are Yamanaka factors. So Yamanaka factors are transcription factors, 4 different ones, that when introduced to a cell can return a cell from a differentiated cell, let's say a skin cell or an intestinal epithelial cell, back to its pluripotent stem cell state. So this could be a therapeutic strategy in the future to kind of reverse some of the damage associated with aging. And then finally, when we're looking at the epigenome and how it's affected, our environment and stress really contributes to DNA methylation patterns, histone changes that have a dramatic effect on our longevity and show us that it's really these epigenetic changes, these changes in how our genes are expressed, that is linked to aging and the associated diseases that aging brings. And so one question we might ask ourselves is there a fountain of youth? How would we approach a fountain of youth? And I'll tell you that from what I've read, there's no quick fix. There's no gimmick. There's no special fountain of youth pill. And I don't think there's any place where we can throw water on ourselves and all of a sudden be immortal. All right. But there are some targets that we can look at specifically that influence how we age. Now, one scientific paper that I want to direct you to, it's really just a review, but this is called The Hallmarks of Aging, an Expanding Universe. And this describes the targets that we can look at if we want to cure aging as a disease. And so what are some of these targets? Well, there are 12 in total. And when we look at it, we look at genomic instability, which is an accumulation of DNA damage over time. That increases mutation rates, contributing to cellular dysfunction. There is telomere attrition. So telomeres are at the end of our DNA strand. They shorten with each cell division, and eventually they lead to cell senescence or apoptosis. Epigenetic alteration, so changes in gene expression due to DNA methylation and histone modifications. We talked about that. Loss of proteostasis, so the decline in the maintenance of properly folded proteins, leading to cellular stress and protein aggregation. Think about beta amyloid and Alzheimer's disease. Compromised autophagy, so a decline in the ability to recycle cells. And if we can't do this, we can't remove damaged cells, and that can exacerbate cellular aging. Deregulated nutrient sensing. So pathways that sense and respond to nutrients become imbalanced, impacting metabolism and cell growth. Mitochondrial dysfunction. So mitochondria, these are the powerhouses of the cell. They generate all the energy. And so when mitochondria lose efficiency, it results in reduced energy production and increased oxidative stress. Cellular senescence. So stressed cells stop dividing and they secrete inflammatory factors, and this disrupts tissue function. Stem cell exhaustion. So if we have reduced stem cell activity, we're diminishing tissue repair and regeneration. Altered intercellular communication. So inflammation and other disrupted signaling happens, and that happens between cells, resulting in accelerated tissue aging. Chronic inflammation, so persistent low-grade inflammation contributes to multiple age-related diseases. Cerebrovascular disease, cardiovascular disease, chronic respiratory disease, all the diseases, including cancers. Dysbiosis, so this is an imbalance in the gut microbiome, impacts immune and metabolic health. And so when we look at all of these and think about aging, these now represent our targets. So is there anything we can do with this information? Can we effect these hallmarks of aging? And the answer is absolutely yes. And over the next few weeks, I'm going to talk about behavior changes as well as some therapeutic strategies that can target these hallmarks. And when I introduce something like diet and nutrition, I'm going to go back to these hallmarks and introduce evidence that shows you how that behavior change or that therapeutic strategy may change a specific hallmark. All right, so let's take a look. How could we affect some of these hallmarks of aging? And so first we have diet and nutrition. So for example, caloric restriction without malnutrition can positively affect longevity. When we look at physical activity, that is so important, and regular physical activity, resistance training has been shown to induce beneficial epigenetic changes in not only our muscle, but other tissues and organs. Stress management and mental health. So practices like mindfulness meditation have been shown to affect gene expression. One study showed that mindfulness practitioners had lower levels of methylation on genes associated with inflammation compared to people who were not meditators. Sleep is incredibly important, and quality sleep is linked to the proper functioning of genes that regulate cellular repair and stress responses. Environmental exposure. So, like I talked about, cigarette smoke and pollution has been linked to increased methylation of tumor suppressor genes, contributing to cancer and other age-related diseases. Hormesis, a concept I talked about earlier about exposing the body to mild stress, can introduce positive and protective epigenetic changes. And then there are some supplements and pharmacological interventions. But what I wanted you to get from today was looking at aging not as this inevitable progression from being young to being old and then having all these diseases and then succumbing to those diseases, but it's choices that we can make now, no matter how old we are, to increase and improve our health span and our lifespan. What if we could add 10 years, 20 years, 30 years? What would that mean? That might mean that we get to see not only our grandkids be born, but we get to see them married, and we get to see our grandchildren have children, and maybe even their children have children, and all the experiences that go with that. So I hope you found this valuable today. In the next video, we're going to be talking about diet and nutrition and its relationship with aging. Specifically, I'm going to get into caloric restriction and the evidence on why that can make such a positive impact in longevity. And so if you want to take a look at another video, check this out. This is a video that I did a few years ago on nutrition. Now, understanding nutrition is absolutely important, not only if you're a doctor, but if you just want to live a long, healthy life. So check out that video. Stay safe, whether you're a student or not. You should be studying hard. Take a deep dive into those things that excite you. And I will see you in the comments, and I'll see you next time.